Let's look at this structured question. Diagram 7 shows a chemical cell. So between zinc electrode and copper electrode, we need to identify which electrode goes through oxidation and which electrode goes through reduction. So let's do a quick revision. If oxidation happens at a certain electrode, that electrode will be reducing agent. If reaction happens at a certain electrode, that electrode will be the oxidizing agent, where the oxidizing agent is. Okay, so we have to refer to this standard electrode potential. Remember I taught you put your right hand up and put your left hand down. Your right hand is reducing agent where oxidation happens, and your left hand is oxidizing agent. And oxidizing agent is the substance that goes through reduction. Okay, so between zinc and copper, between zinc and copper, we can see that zinc will be the reducing agent, okay, and copper will be the oxidizing agent. So zinc is the reducing agent and copper is the oxidizing agent. Zinc goes through oxidation and copper goes through reduction. Okay, zinc is the reducing agent. On your right hand, the one that's higher, okay, goes through oxidation. So which electrode is the positive terminal? Okay, so let's write the half equations for both of these oxidation and reduction reaction. Okay, we have learned that for oxidation, okay, the substance loses electron. Okay, so we write down zinc lose electrons and it becomes positive ion. Okay, so it loses electron because zinc goes through oxidation. Now, so therefore, there will be a lot of electrons, okay, a lot of electrons that are released around the zinc electrode. Okay, therefore this zinc will be the negative terminal, and that makes copper the positive terminal. Okay, what happens at the copper terminal is that the copper 2 ion in the solution, okay, receives the electrons that are given out by zinc. Okay, the electrons flow through the external circuit, okay, through the wires, through the connecting wires to copper electrode, and copper 2 ion in the solution will receive the electrons to form copper. Alright, so copper is the positive electrode. So copper is the positive terminal, not positive electrode, positive terminal. Copper is the positive terminal. Alright, which substance will undergo reduction? So we know that copper will undergo reduction. Okay, copper, and let's copper 2 ion, okay, or you can also write it as copper 2 plus, Cu2 plus. Okay, this is the substance, okay, copper 2 plus, that undergoes reduction. Copper 2 plus is reduced. Some of you may put copper 2 sulfate solution. That can be accepted too. Copper 2 sulfate solution can also be accepted. But make sure you write the word solution. Okay, explain your answer. So you can say copper 2 plus ion gains or receives electron. Okay, because that is the half equation that we have written earlier. Receive electron, so therefore it goes through reduction. So therefore copper 2 plus ion or copper 2 sulfate solution goes through reduction. And copper 2 plus ion receives electron. Please do not say copper 2 sulfate solution receives electron. It's wrong, because it's copper 2 plus ion that receives electron. Next question. Write the cell notation. Okay, write the cell notation. So we always start with the negative terminal, right, which is zinc. And then we have the solution. Okay, in the solution there is zinc ion. Okay, the zinc becomes ion. All right, the zinc loses electron and becomes the ion. Okay, so zinc loses electron, becomes Zn2 plus ion. Okay, and on the other side, positive terminal, okay, in the solution, the Cu2 plus receives the electron. Okay, and the electrode is a Cu electrode. So this is the notation. And we want to calculate cell voltage. Okay, so we want to calculate cell voltage. So we always take the right side. Okay, Cu. So you look at the standard electrode potential again. Cu is plus 0.34. Zn is minus 0.76. 34 and 76. Okay, so the right side one, reduction, minus the left side oxidation. Okay, so you have here plus 1.10 V. Okay, so that is your 3 marks. 1 mark for notation and 2 marks for the calculation.